Plateau Uplift, page 236 of In the Beginning by Dr. Walt Brown. Hydraulic lift. Hydraulic lifts are in elevators, car jacks, automobile brakes, and mechanisms that launch planes from aircraft carriers. In this schematic of a hydraulic lift, a large downward force or weight on the right side moves a short distance and lifts a lighter weight on the left a long distance. In other hydraulic lifts, a weaker force moving a long distance lifts a heavier object a short distance. The liquid transmitting the force can be water, oil, or for rising plateaus, magma. The sinking Rocky Mountains acted as a gigantic force that pushed 2,500,000 cubic miles of magma under the Colorado Plateau, lifting it an average of 6,200 feet above sea level. The world's other plateaus rose the same way, all driven by gravity, beginning immediately after the crashing hydroplates pushed up mountains. Although the roof of the subterranean chamber almost completely collapsed onto its floor by the end of the flood, high-pressure magma easily migrated between those surfaces. The sinking of the massive Himalayas pushed about 25 million cubic miles of magma and crushed rock under the Asian Tibetan Plateau, lifting it 3 miles. To understand why plateaus perplex geologists, see Professor Kennedy's candid statement of the problem on page 129. The hydroplate theory provides a simple explanation. The Kaibab Plateau is not a true plateau and is more correctly called the Kaibab Upward because its sedimentary layers arch upward, a result of the water balloon effect explained on figure 134 on page 237. That's over here. When you squeeze in, something bulges. Okay, and here's the hydraulic, how the plateaus rose up as the mountains sank in. Okay, the Kaibab Plateau is not a true plateau, and is more correctly called the Kaibab Upward because its sedimentary layers are arched upward as a result of the water balloon effect and the rising of the much larger Colorado Plateau, a true plateau because its layers are horizontal. Likewise, the buckling and crushing of the massive Rocky Mountains during the compression event near the end of the flood lifted the Colorado Plateau. Italicized definition of a plateau on page 230. A plateau is a large region whose horizontal sedimentary layers were lifted relative to the corresponding layers surrounding the plateau. As the Rocky Mountains slowly settled into the upper mantle, sliding friction crushed and melted the rock below and injected the magma between the former floor and roof of the subterranean water chamber where resisting forces were weakest. The Colorado Plateau then rose as if it were resting on thousands of hydraulic lifts. Below the Earth's surface, the magma lubricated and swept the flow of melted and crushed rock, called xenoliths, away from the flanks of the sinking Rockies. Each narrow channel of flowing rock and magma constituted one hydraulic lift. Most of the energy expended by the sinking Rockies lifted the Colorado Plateau, melted rock, and produced lava flows and volcanoes. The Colorado Plateau did not rise as one solid block because the pressure below grew at different rates at thousands of locations. Whenever the pressure at one location became large enough to fracture the rock above, a sudden but limited upward jerk occurred. Each fracture event was an earthquake, and each sliding surface was a fault. Thousands of faults are identified and mapped on the Colorado Plateau. Undoubtedly, thousands more are too deep to detect. Many uplifted and tipped blocks, some hundreds of square miles in area, such as Utah's Grand Staircase, dramatically show what happened. Why was the uplift limited? Sometimes the irregular sides of a rising block wedge against an ancient block. In most cases, magma, the hydraulic fluid, was not produced fast enough to replace magma loss and to keep the channels, hydraulic lines, fully pressurized. For example, some magma escaped into cracks or up to Earth's surface as volcanoes or lava flows. Page 128 lists some long-standing mysteries concerning volcanoes. Large volcanoes and at least 76 lava flows are in the Grand Canyon area. Finally, the higher a block rose, the greater the pressure needed to lift it higher. Therefore, the magma below, containing dissolved water, spread laterally, so adjacent blocks which had not risen as much were lifted instead. Spreading magma was like an expanding ink spot, which is why the Colorado Plateau and other plateaus are generally circular. A block rose when the upward force produced by the magma's increasing pressure below that block exceeded the total downward force. The block's weight plus resisting stresses and friction. The block's weight exceeded the total downward force. The block's weight plus resisting stresses and friction. Plateau Uplift, page 236, from In the Beginning by Dr. Walt Brown, found at creationsciencecenter.org.